So my name's Zach. I'm a UX researcher and architect with GE Global Research. And I'm going to talk a little bit about asset performance management from a much more abstract perspective, I think, than a lot of the other use cases we've seen today. There's a couple of reasons for this. One is the limitation of 5 minutes. The other is the nature of the work, which is pretty confidential, although we've heard from the Army and the Navy already. So I feel a little silly saying that, but the way it is. So work with me here. I'm going to go out on a limb, and I'm going to push the boundaries of abstraction here a little bit. So superpowers, they enable us to do things we can't normally do, same as augmentation. Both superpowers and augmentation are about the individual. They're very much about head-mounted displays. In this, if you have been to any of the other presentations today, you've seen a lot of HMD work. So organizations don't always share the same perception that we have with our vision. So let's talk about what reality means. Let's take a step back and talk about that for what it is for organizations. So humans have bodies. All of our cognition is embodied in our vision. Organizations don't have this. They think about abstraction. Humans are in a place. Your body is located in place and time, and organizations are an ecosystem. They're a network. Humans have size. We have a human scale. You think about the way that tools are designed for our usage. There are affordances like hammers that fit very well in our hands. Organizations have no sense of scale that we share. Obviously, we're very subjective. Organizations are data-driven, and we're very emotional. We make decisions emotionally, whereas organizations, while they can be emotional, are also analytical. So almost anything can really be perceived as augmented. In this case, let's take the example of a map. Maps really are about seeing where you are in place and time. It's about perceiving your location there. So taking them out of your head, making these pictures, drawing this map, and making them real and interactive is essentially a kind of augmentation of your cognitive processes. The process of externalizing that lets you then interact with it, which changes the way that you perceive it. So what I'm driving at here is that we should take a broader view of augmentation. In this case, if anybody's seen the movie Interstellar, I'm going to loop back here to the whole superpower part of this. You're familiar with the concept of Tesseract, and this is what I'm driving at in terms of what we should think of in pushing the boundaries for augmentation. It's not just heads-up mounted displays. It's not just our visual cortex. It's the ability to perceive things that we couldn't normally perceive given our cognitive limitations. So more concretely, this could be something like networks. It could be something like multi-parameter assets. So in this case, tying this back to asset performance management, you might have, for example, a piece of a turbine, for example, a piece of hardware, industrial hardware that has many parameters, speed, temperature, vibrations, things like that are collected from it. And perhaps an analyst would like to model this. And this isn't something that you can see easily on a head-mounted display necessarily. You can certainly do that, but really the ability that we're looking for is the ability to model these things and then test different parameters against them. So a lot more complicated than maybe what we can do with an HMD. So again, the technology changes, but it's all about the HMD so far. So what we want to do is take that idea of situational awareness that the HMD can provide and take that and move that to the concept of the ecosystem or the network awareness. Again, Mihaly Csikszentmihalyi, this psychologist, has a concept he calls flow, which maybe some of you have heard about. Flow is a very powerful tool when you think about it. It's the loss of perception of boundaries between yourself and your tool set. You might experience this when you are working and suddenly you realize a bunch of time has gone by and you haven't even noticed. So what I want to challenge you all to think about is what does flow look like in the sense of data visualization, where we move away from situational awareness and we move to network awareness. And I don't have a good answer to that. This is interesting stuff, but not defined in any way that I've seen. So we might think of this as an interface problem, and certainly I've set it up that way in my presentation so far. That's not necessarily the head-mounted display. It's really about the limitations there. So I think there's a convergence of tools, the machine learning paradigm, the Internet of Things, and data visualization. And I'm going to take data visualization as my starting point because that's really where I work for the most part. So let me give you an example here. this is a set of numbers, and it's very difficult to pull out the highest numbers in this matrix very quickly and easily. Now, we just augment this with some color coding very simply, and you could see this through your head-mounted display. It makes it intuitive, it makes it readable. It's not a stretch to think that you could pull out trends or anomalies, clusters, or some kind of pattern. So what? So this is really just the start. The value comes when we start augmenting the data with machine learning techniques that let us see these anomalies and patterns and clusters. To be effective, we need to have a lot of data, and we need to be able to access. It needs to be accessible instantaneously. So, just give us a map. Just as a map, as a holistic view of a place, the data gives us a view of an asset. Again, going back to the turbine, it could be all of its performance history, parts, mechanical drawings, imagery, repair history, who owns it. All these things give us a digital twin, to use that terminology, of what this asset is. So that makes it manipulable, and that gives us things like this. It gives us an understanding of how it's going to perform, no unplanned downtime, when there might be things like failure modes and what those failure modes are. So this is the power of analysis, and in keeping with the theme of this conference and superpowers, I'm going to make the claim that I think analysis is actually more powerful than omniscience, the superpower equivalent. And the reason for that is that it's more important to know why something is the case than to know that it is the case. And just as mathematics relies on proofs, knowledge is about understanding and not omniscience. So these are complex problems. They're dimensional. They scale across many variables, many conditions, and time periods, as well as many other potential data points. Solving them doesn't really mean a yes or no answer necessarily. It means extracting knowledge about the problem space and then making a decision based on that. I think that AR can be a valuable piece of hardware or a tool set in this case, but we've definitely got a long way to go, and I challenge you to push your boundaries a little bit in terms of thinking about what AR is. Thank you very much.
Great. All right, so it looks like we have time for a question. If anyone has any questions for Zach? No? Thank you very much, Zach.
Thank you.